Welcome to another video for chemistry. In this video, I'm going to be discussing atomic mass. This is an introductory video which will lead up to dealing with the mole, Avogadro's number. And in this series of videos, towards the end, I believe it's the third video, I'll be working out some of the problems in the textbook to show you how this principle is applied. All right, so let's first talk about this idea of atomic mass. Okay, so in the periodic table, we're going to highlight carbon. Okay. Now this is the symbol for carbon that you'll see in the periodic table. There's three things that we're going to highlight and discuss in this particular video. Number one, the atomic number, the atomic symbol. The atomic symbol in the periodic table will usually be a capital letter. It will always be a capital letter. If there's a second letter, it'll be a lowercase letter. Okay, so carbon only has one, so you have a capital C, and then you have the atomic mass unit, AMU. Okay, this is the number that we're going to highlight in this video. There's two ways that we're going to look at this video. Two ways that we're going to look at this number, okay? It gives you a lot of information. The first way that we're going to look at it is average mass, and then we're going to look at it as the mass of a mole amount of that substance. Okay, I'll discuss in more detail what that exactly means, because that can be pretty confusing sometimes, but hopefully with this video I'll be able to make it a little bit more understandable. So let's first discuss average mass. What does that mean? 12.01 that you saw. Now, there are many different types of carbon in nature. You have, here I have three, carbon 12, carbon 13, and carbon 14. There's actually quite a few more, but we're going to just stick to these for now. Now, what that means is that, what these are isotopes. Okay, isotopes are pretty much the same element, but the only difference is that they have different number of neutrons. Okay, so they all have 6 protons. Always, especially for carbon. Carbon always has 6 protons, which is also the atomic number of carbon. If you add any more protons or you take away any more protons, then you're changing the element altogether. For example, if I add one more proton to this, then I change it to nitrogen. So the protons are always going to be the same. It's the neutrons that change. So for carbon 12, for example, now if you remember the atomic mass of carbon was 12, so that means there must be 12 neutrons. For carbon 13, it always has 6 protons, so that means it has 7 neutrons. Carbon 14, again, it always has 6 protons because that's how many carbon has. So that means if its mass is 14, then that means that its nucleus has 8 neutrons to it. So again, an isotope is an element, it's the same element with a different number of neutrons. Okay, so how does this play into the average mass? Okay, so if I look at the different carbons that are in nature, 98.9% of them are of carbon 12 variety. 1.1% are carbon 13, and 0.0001% is carbon 14. So it's not a lot of carbon 14 in nature. So here's that little pie chart showing the amount. So as you can see, carbon 12 by a massive amount, that's where most of the carbons in nature are made out of. Okay. Sorry, let's go back here. So let's see how we get this number 12.01. Why doesn't it just 12 flat out? Well, because this is an average mass. This isn't actually an exact mass, but an average mass of the carbon isotopes that exist in nature. So if I go back to my different carbons that I highlighted earlier, I can get the mass of each of these by converting the percentages into their decimal, right? So what I'm going to end up doing is multiplying carbon 12 by the decimal form of 98.9%, which is 0.989, and I'll end up getting 11.868. Okay, and then for 13, I'll multiply it by 0.011, and I end up getting 0.143 grams. Okay, and then for carbon 14, again, there's not a lot of them in nature, so it only contributes a small amount to the overall mass of carbon. So if I look at the top here, the top contributes almost 99% of the mass, so that's 11.868 grams. And if I add all of these together, I end up getting 12.01, which is the total mass of all of my carbon isotopes and the amount that they contribute. Okay, and that's how I get this number 12.01, my average atomic mass unit. So the same thing with nitrogen. Nitrogen, I have nitrogen 14 and nitrogen 15, which means I have 7 protons, but carbon 14 has 7 neutrons, carbon 15 has 8 neutrons. So in order to get the average atomic mass, we need to look at the percentages and how much each of these isotopes exist in nature. So if I look at nitrogen 14, I see that 99.63% of it, of all the nitrogen, is nitrogen 14, and 0.37% is nitrogen 15. So just right off the bat, if I look at the percentages, I can have a really, really good guess as to what my average atomic mass is. Since 99% of it is nitrogen 14, I can guess that the average atomic mass is going to be very, very, very close to 14 and not 15. Okay. Likewise with my carbon, since again, just like this one, 99% of it was carbon 12, I can guess that the average atomic mass is going to be really close to carbon 12 as opposed to carbon 13 or 14. So just like the previous element, carbon, I can use the percentages for nitrogen to find how much mass each of these isotopes is contributing to the overall mass. So I'm going to change it to the decimal form, and I can multiply 14 by 0.9963, and I find that that's 13.9482, and nitrogen 15. So that's how much each of these elements contribute to the average atomic mass. And then when I add them up together, I can see that my mass is 14.007 atomic mass units, which is where we get this atomic mass unit number in each of the elements that you see in the periodic table. Okay? Well, that does it for atomic mass. Now let's go ahead and take a look at Avogadro's number and how this number relates to that.